Hello friends, it is a NPTEL DBMS 2019 July week 1 assignment. Now coming to the first question, question number 1. Consider the SQL statements below. S1, S2 two statements are given. S1 is a create table statement. S2 is select statement. Now the question is identify the correct statement. Options are given. Both S1 and S2 are data definition language, and by looking these options, so it is to classify what kind of statements it is: data definition and data manipulation language. So first we should know we have two types of database languages. Those are data definition language, we call DDL in short, and data manipulation language. Data definition language deals with database schema. Okay, it is dealing with database schema. Data manipulation language deals with data in the database. Data in the database. So means the commands that comes under DDL is create, alter, drop. These all comes under data definition language. Data manipulation language: insert, delete, update, event select comes under data manipulation language. Now see, S1 is a create table. It means S1 comes under data definition language. S2 is select, so that it comes under data manipulation language. Option is given. Both S1 and S2 are in data definition language. Incorrect, because S1 is DDL, S2 is DML. Option B is S1 is a data control query and S2 is a data manipulation language. See, actually here it is given data control query. Data control query language contains save point, commit, rollback. This is more classifying the database languages. Means not just DDL and DML. Means DDL and DML are the two broad ways of classifications, and there are another classifications of database languages we call data control language, transaction control language, right, and data query language. So many classifications are there, but S1 is data control language is incorrect, so option B is incorrect. Now option C, both S1 and S2 are data manipulation language. Again it is incorrect, because S1 is data definition language. Now coming to option D, S1 is data definition language, correct, and S2 is data manipulation language, correct. So answer for this question is option D. Coming to question number 2. Identify the set difference operation. Set difference operation. We have three types of set manipulation operators. We have three set manipulation operators called union, which is represented with U, intersection, reverse U, and minus. This union, intersection, and set difference to be used between two relation instances, say R and S. If and only if the two relation instances are compatible. If and only if the two relation instances are compatible. The compatible in the sense both R and S should have same number of attributes. That is the first condition. Suppose AB, this is CD. Two attributes, same number of attributes should be there. That is the first condition. And second condition is the domain of corresponding attribute should be same. Say domain of A is int, then domain of C also should be int. Domain of B is char, then domain of D also should be char. Then we can call compatible. And here union combines the result of R and S. Intersection combines, intersection select the common tuples of R and S, and this minus will select the tuples of R but not S. So minus is for set difference. Okay, minus is for set difference. Now directly we can answer the question, that is option B. Why? Because it is subset. Subset is not set operator. It is not a set manipulation operator. It is not a set operation. Minus is a set difference. It is set difference. It is intersection. It is a Cartesian product. It is Cartesian product. So option B will be the correct answer for the question. Coming to question number 3. Identify the valid primary key for the relation student info. Identify the valid primary key for the relation student info. The first condition for primary key is should not have duplicates, means no duplicates in the primary key. That is the first condition. The second condition for primary key is no null values. So to answer this question, these two conditions to be verified. And fortunately, all the columns are specified with some value and no column is having null value. So means I need not to check for 2. 2 is satisfying because nulls are not there. So to be a primary key, it should not have duplicates. Student ID, here you can see both tuple 1 and tuple 4 is having same student ID. Primary key should not have duplicates, but student ID is having duplicates. So option A is wrong. Option B says student ID and name combination is a primary key. So what does it mean? This combination, if duplicated, it no longer be a key. Now look, 1 Rohan, this combination I am looking now. And again 1 Rohan. Even this combination is also duplicated because duplicates are there. It is no longer be a key. And option C says student ID, course ID. Student ID, course ID. What student ID, course ID? We have 1 C1, 2 C1. Now when C1 is duplicated, means course ID is duplicated, student ID is different. 3 C2, 1 C2. Again course ID is duplicated, student ID is different. And observe this first and fourth tuple. Student ID is same, course ID is different. And 4 C2. So means all these combinations are unique. Then we can say option C is a primary key because it should not have duplicates of these two combinations, because these two combinations is a primary key. So option C is the correct answer. Option D, you look one more time. D, course ID comma name. Course ID C1 physics, this combination, and course ID C1 physics. This combination is duplicated. Because these duplicates are there, course ID comma name is not a primary key. So answer for the question is option C. Coming to question number 4. Here it is given two relations. R with attributes ABCD, S with attribute BDE. Now question is, an operation on these two relations produce the following output. This is an output of some operation between R and S tables. Now question is, identify the operation. First option, R minus S. Here just now we discussed minus is a set operation because set operations requires compatible relations. What is the condition for compatible relations? The first condition should have same number of attributes. But you look in R table and S table. R table is having 4 columns, 4 attributes. S is having 3 attributes, means it is not union compatible. Because not compatible, then option A is incorrect, option B is also incorrect. Why? Because option B is also union operation, we call it set operation. Set operation requires compatible relations, which requires same number of attributes. Second condition is domain should be same. Domains also should be same. But the first condition itself is failed, so that we conclude that option A and B are incorrect options. Now coming to option D. R Cartesian product S. It is a cross product. See, how many tuples in R? 1, 2, 3, 4, 5. 5 tuples in R. How many tuples in S? 1, 2, 3, 4, 5. 5 tuples in S. The result of Cartesian product contains 5 into 5. 25 tuples should be there in the result of Cartesian product. But here the output contains how many tuples? 1, 2, 3, 4, 5 tuples itself. So that definitely it is not the Cartesian product. So option D is incorrect. So what is left is option C, that is a join operation. It is correct. So what is join? Natural join. Natural join is a join between two tables with equal condition on common attributes. Now what are the common attributes of R and S? B, and one more is T. So means it is a condition that R natural join S. What does it R natural join S? Means R is joined with S on common attributes. RB equal to SB and RD equal to SD. This condition to be satisfied. Now look, 1 match with 1 true and A match with A true. This is one combination. 1 match with 1, A match with A, that is also correct. BB and DD. Now 2 match with 2, but D is A, but this is B. This is do not have a match. And 4 does not have any matches. And 1 A is matching with this tuple because B is 1, B is 1, D is A, D is A. And similarly, this 1A is also matched with this tuple 1, 1, A, A. And 2B, 2B. 2 matches, B, B matches. So how many tuples we have in the output? 1, 2, 3, 4 and 5 tuples in the output. These are the 5 tuples. So answer for this question is option C, that is the result is same as R natural join S. So answer for the question is option C. Coming to question number 5, identify the correct type of join which returns all matched or unmatched rows from the table. So it is to find both matched as unmatched rows. As you know that join, generally we can call equijoin, gives you matching rows. Let us say this is table A, this is table B. If you perform equijoin between table A and table B, you can get this matching tuples in the outputs. If I say left outer join will give you matching rows as well as non-matching rows in the left side table. Means suppose A left join B, we can say matching rows as well as non-matching in the left side. So now A left join B means to the join which is a left A, so all non-matching in the A in the output. When it comes to the right join, suppose A right join B, you can see all matching rows, this part, along with non-matching rows in the B. This part also you can see in the outputs. Now when it is say full outer join, which is a union of left and right, means you can see matching rows from matching rows and also non-matching rows from A and also non-matching rows from B, all in the output. So among the options, which is the most appropriate option? Option C is the most appropriate answer. Coming to question number 6. The question number 6 says, identify the correct operation which produces the below given output based on two relations R1 and R2. So these are the two relations are given, and question asked is, this output is representing which of the following operation, which of the operations. Now look, option A says R1 intersection R2. What intersection finds? Intersection finds the common tuples. Intersection finds the common tuples of R1 and R2. Now observe the common tuples of R1 and R2. Now Mira phi is there in R1. Mira phi is also there in R2. So Mira phi is in the output. This is a common tuple. So that answer is option A, R1 intersection R2. R1 minus R2. Minus is called set difference. It says R1 but not R2. So means it is there in R1 table but not in R2 table. You look, when I perform R1 minus R2, you can see name, class, which are there in R1 but not in R2. Raj 9 is there in R1 but not in R2. So Raj in the output. Mira phi is there in R1 and also R2. Mira phi is not in the output. Saurav 12 is there in R1 but not in R2. Kirti and is there in R1 but not in R2. This is output of R1 minus R2. So option B is incorrect. Option C says R1 minus R1 minus R2. Now what is R1? This one. R1 minus R2 just now I have written here. So R1 minus R2 means the tuples that are there in R1 but not in R2. Here I am writing clearly R1 minus of R1 minus R2. So it finds the tuples that are in R1 but not R2. That is name, comma, class. Raj 9 is there in both R1 and R1 minus R2. So Raj 9 will not be in the output. Mira phi there in R1 but not in R1 minus R2. So that Mira phi is in the output. Saurav 12 is there in both. So it is not in the output. Kirti 10 is there in both. It is not in the output. So output of R1 minus R2 is just Mira phi. That is this answer. So option C is also correct. R1 union R2. Union will have all the tuples of R1 and R2. So it is definitely wrong. So answer for this question is both option A and C. Coming to question number 7. The question is identify the incorrect statements. Question is incorrect statement. Now coming to option A. A candidate key is a minimal set of attributes. Yes, it is a minimal set of one or more attributes that taken collectively allows us to uniquely identify any entity in the entity set. Now what is a minimal set of attributes? Suppose the set of attributes A comma B is a candidate key. It means no A alone, no B alone is a key. Means suppose A1, B1, A1, B2, A2, B1. It does mean that if I remove B, A alone is not a key because we have a duplicates in A. Means A is not a candidate key. If I remove A, B alone is not a candidate key because you have duplicates in the B. That's what we call it is minimal set. Minimal means no proper subset is a key. I'm writing clearly. If no proper subset is a key, is called minimal key. Correct statement, but question is incorrect statement. So option is wrong answer. Coming to option B. A candidate key for which no proper subset is also a candidate key is called a super key. If no proper subset of a candidate key is a candidate key, it is called candidate key. It is called candidate key, but not super key. But not super key. So because it is not super key, so option B is incorrect statement. Because question is incorrect statement, answer is option B. Option C says a super key is a set of one or more attributes that taken collectively allows us to uniquely identify any entity in the entity set. Yes, this is one or more attributes that uniquely identifies an entity in the entity set is called super key. So option C is correct. Because correct, question is incorrect, option C is wrong. A super key for which no proper subset is also a super key is called candidate key. And here you should understand a point, every candidate key is also called super key. If it is super key, no proper subset is also super key is called AB is a candidate key, and the proper subset A or B is a super key, because neither A is a key nor B is a key, we call it as a candidate key. So option D is also correct statement, but question is incorrect, so option D is false. Coming to question number 8, it is given, consider the two relations below. The primary keys are underlined. So it means the primary key of employee is employee ID, primary key of department is department ID. The question is, identify all possible foreign keys from the options based only on the two relations. Possible foreign keys. Now observe these two. What is a common attribute of employee and department? Employee ID is not there common, employee name not common, department ID is common. And here department ID is common, and department ID in the department table is primary key. Then department ID in the employee table will be foreign key. So what is a possible foreign key? Department ID. That is an option B. Coming to question number 9. The question is, identify the invalid data type. Invalid data type in SQL. The data types in SQL are char types, varchar, varchar2, and int, and we call number. These are called numeric types. We have date, we have time, we have date time, and so on. Some data types we have. Now question is invalid data type. Varchar2 is a valid data type, numeric types we have, date types we have. But here you observe SAP is given, which is not belonging to any data type of SQL. So the question is invalid data type. So these are valid data types. Invalid data type is SAP. So answer for this question is option B. Coming to question number 10. Identify the correct statement. Here a employee ID comma employee name is a relation instance. What it specifies, it is a table name. These are the attribute names. Means it is specifying the structure of employee table. So we call it is a relation schema. We call it is relation schema, but not instance. Option A is incorrect. 12 Jessica, we can call these are values, is an instance of a relation schema. It is perfectly correct. So means question is correct statement. Answer is option B. 12 Jessica specifies a relation schema. Incorrect, because schema specifies the structure, but it is not structure. This is data. The data is called instance. Okay, this data is called instance, means at that particular time this is a data in the table. So option B is correct. Option D says 12 Jessica is neither a schema, okay, it is correct, nor a instance. It is incorrect. So that option D is also incorrect. So answer for this question is option B.